This is lesson 9.3, part 2. In this second part, we will use the generic formulas for explicit and recursive to write formulas for geometric sequences. Okay, so these are the formulas. You should have written them down on the previous video. And here's our first question. What is the 10th term of the geometric sequence 4, 12, 36, etc.? So first of all, let's write a recursive formula. For the recursive formula, we have to have a starting point, so we'll just start with a sub 1 since it's convenient. A sub 1 is 4. Then to find any additional term in the sequence, we would take a previous term, a sub n minus 1, and multiply it by r. Okay, so we need to figure out what r is. And since r is our common ratio, we take 12 divided by 4 is 3. So we find out that that would be a sub n minus 1 times 3. So if we want to know the 10th term, we would have to find all 3 terms we already have, and then 6 more terms, and then the 10th term. So it's not really super helpful here to find the 10th term using the recursive formula. So let's write an explicit formula. In the explicit formula, we have a sub n equals a sub 1 times r to the n minus 1. So a sub 1 is 4, our common ratio is 3, and we put n minus 1 there as an exponent. That's the explicit formula. So to find the 10th term, we're looking for a sub 10. We would just put 10 in for n. According to the order of operations, you would do your exponents first. So that would be 4 times 3 to the 9th. 3 to the 9th is 19,683. And then we would multiply that by 4. And we get a sub 10 equals 78,732. As with the arithmetic sequence, you have an arithmetic mean. There's also a geometric mean. So if you have 3 terms in a sequence and you're missing the second of the 3 terms, then you can use the geometric mean formula to figure out that middle term. So we would say square root of 3 times 12, which is a square root of 36, so that's 6. So this term in the middle is 6. If you calculate your common ratio, 6 divided by 3 is 2. 3 times 2 is 6. 6 times 2 is 12, so it works. Okay, this problem's a little bit more challenging where you're missing 2 terms. So if we're missing 2 terms, we can use our explicit formula, a sub n equals a sub 1 times r to the n minus 1. And we will plug in this term for a sub n. And a sub 1 is 2. But we don't know our common ratio, so we're going to have to solve for that. We do know that negative 54 is our 4th term. Since this is our 4th term, we're going to put 4 in for n. So that's what we have for our formula. So 4 minus 1 is 3. And solving for r, we would first divide by 2. So we get negative 27 equals r cubed. And then take the cube root. We find out that r is negative 3. Since our common ratio is negative 3, we know that we're just going to take 2 times negative 3 to get our middle term, or our second term. Negative 6 times negative 3 gives us our 3rd term, and 18 times negative 3 does give us negative 54. Okay, we'll finish up this lesson with a couple story problems. So when a ball bounces, the heights of the consecutive bounces form a geometric sequence. What are the heights of the 4th and 5th bounces? So if we assume that 100 is the first bounce and 54 is the third bounce, we can use the geometric mean, 100 times 49, take the square root of that, to give us the second bounce, and from that we should be able to find the common ratio. So the geometric mean is 70, so we know our second bounce here is 70. So the common ratio would be 70 divided by 100, which is 0.7. So then we can write an explicit formula. A sub n equals A sub 1 times r to the n minus 1. So if we want to know the fourth term, A sub 4 would be 100 times 0.7 to the 4 minus 1 is 3. And that comes out to 34.3. The fifth bounce, A sub 5, would be 100 times 0.7 to the 5 minus 1 is 4, which is 24.01. So we did this using an explicit formula, but we could have done it with a recursive formula also. If we take 49, multiply it by 0.7, that will give us our fourth bounce here, which is 34.3. Take that answer times 0.7, and it gives you your next bounce. And that finishes lesson 9.3 about geometric sequences.